Mr. Arnold coming in on November 30th. These are for the people who have missed chemistry today, and we thought we'd give you a little update here. Now we're going to apply the type of reactions that we learned the other day from the dance video to actually finishing reactions. So we're going to start off with a little review. If you look here on the paper, you'll see that I have the 4 types of reactions now. They're not in the same order as they were during the video because I accidentally left the decomp off on this one. So if we look at this here, we have synthesis, which is what we called when the 2 people met and became dance partners. Then we had our single replacement, which is where someone came in and cut in with the dance couple and took over. So may I dance with your date? Well, certainly. Go ahead. And the one person was kicked out of the reaction. And then finally, our double replacement where we have 2 couples and they switch partners. And again, you have to take in consideration the charges because opposites attract. So the positive and the negative are always going to be together. You're not going to have 2 negatives together. You're not going to have any 2 positives together. Positive and negative together, that double replacement. And then decomposition, which is the breakup, where we have a compound that's one and it breaks apart into different amounts. And if you remember the decomp, it was complicated. They're always complicated. And so I don't have a lot of decomps on the things you're going to balance today because I want you to figure out what products are going to be on your own and not rely on another chart or another type of reaction. Okay, so let's get started. First thing we're going to do here is we're going to just going to see what we have, right? We're just going to name these reactions. And we're not going to use the full name. Please don't use the full name. For decomp, just put a D. For synthesis, put an S. For single replacement, put SR. And for double replacement, put DR. And that way it'll be easier for you to write. Oops. Put DR, and let me move myself out of the way so you can see that, oh yes, he did write DR down there. And so it should be pretty easy. Now look at these. What do you have? You have N here. And then you have H. So you have N plus H forms NH together. Right? Say it to yourself out loud. That's right. Hopefully you're saying to yourself, oh my goodness, that's a synthesis. And you're going to write an S down. Okay, let's look at them again. We have an H. Oops, that changed. We have an H. And I can mark both sides at one time because, you know, what's ever on the one side is going to be on the other side, just maybe not in the same format. We have an O. We have an O. So we had 2 together, they broke apart. Oh my gosh, how sad, they broke up. That's going to be a decomp. All right, our next one here. You know what, you can try these and come back and make sure I'm going to go faster after this one. But we have Na, and the Na is with iodide. And then there's this old pesky fluorine here who, hey, they replaced the iodine. Single replacement reaction. All right. Now, plus, minus, look at that. 2 couples. And you look on the other side, hey, they switched partners. Double replacement. Okay, so those are your types of reactions, right? So go through and finish the rest of those and see if you can do them. Now, I did throw a trick in here. This one right here is a combustion, and I'm not going to talk about that too much. We've already done combustion reactions. And this is from an old test, this section was, and that combustion snuck its way in there. So we'll leave that as it is. So go ahead and finish these up and see what kind of reactions they are. And it shouldn't be that hard. You know, just go through it. If you have to put charges above them to do it, or just mark each element as you go and you see the pattern, it'll match up. It should work out just fine. All right, now, the reason we're doing this is because, you know, we want to become chemists. We want to do chemistry. Now, chemistry is not just balancing equations where you put numbers in certain spots. It's not just crisscrossing charges, that kind of thing. We want to know what happens when you put two chemicals together. And what do they become? That's chemistry. That's what we want to know. That's the stuff, right? That's the cool thing. And so let's scroll. Okay, now I marked these, the types of reactions. I probably didn't have to because I know you're so studious you would have figured that out. But look what we have here. Okay, I'll do the first one here for us, and then I'll do a few of them. I'll pick and choose a little bit. So we'll look at this equation here. I had to change my font. That's a little too thick for that. And what we have is HCl, which is hydrochloric acid, plus sodium hydroxide forms, what's it form? Well, I marked it, double replacement reaction, but you can see that, plus minus, and then plus minus, yeah, two couples. They're going to switch partners. Now, remember, positive goes with negative, and positive always leads off. So you have to start off with a positive. It doesn't matter which one, as long as you have them here. Now, I'm going to start off with Na. I don't know why. I just feel like it. So I'm going to put, can you see me there? How's that? Yeah, see, I'm writing it. Oh, there's a coffee cup. So I'm just writing here like this. Okay, so we have Na. And Na is plus 1. Cl. Cl is minus 1, right? We don't need any subscripts for that. Right? Plus 1, minus 1. It's 1 and 1. And then put your big plus sign. Some people haven't been putting their plus sign in there. You know, we have to know they're separate. And then it's going to be the other ions. And that would be, of course, H and OH. Now, I know what you're thinking to yourself. HOH, isn't that H2O? It is. But it's easier to balance HOH because water doesn't react H2O. Water reacts HOH, right? In most cases. So HOH. Right? Plus 1, minus 1. Plus 1, minus 1. Hey, everything's already plus 1, minus 1. We don't need subscripts, and we don't need any coefficients. It's done. All right? So that's how you do a double replacement. Now, some of these double replacements, you're going to have to, should I do one? I'll let you figure it out. You're going to have to do your crisscrosses and your charges. You're going to have to do all that stuff. I want to pick one that you'll have to do that's not a, oh my, OMG? No, MgO. This is a synthesis reaction here. Mg is plus 2. Oxygen is minus 2. Now, subscripts. Subscripts come from the charges. That's where you get the subscripts. What's the new subscripts here? Well, crisscross 2 and 2, well, we know we have to reduce that down, right? So we're going to reduce that to 1 and 1. I wouldn't normally write those in there, but I'm going to right now, all right? That's the formula, right? It's not OMG, it's MgO. Now, once the formulas are all correct, we can balance, and that's correct. So we have 2 O's on this side. We need a 2 in front of that. That gives me 2 Mg's. I need a 2 in front of that. Right? A 1 can go here if you want to, but that is optional. All right? You have to have the formulas correct before you can balance. If you don't have the formulas correct, it's not going to balance anyway. All right, let's look at another one here. There's a synthesis. Let's see. Let's find a nice single replacement. Is there only one single replacement on this whole thing? By golly, there is. Okay, so here's a single replacement here. Notice we have Cl minus 2. Oh, I'm sorry, Cl minus, but there's a 2 there. It's diatomic. And then we have KBr. All right. Well, the Cl is negative, the Br is negative. So the Cl has to replace the Br. You always have to write the positive first though. K plus 1 hooks up with Cl minus 1. Does that need subscripts? 1 and 1? No. No. Right? So don't bring that 2 across that line. No. That 2 is there because Cl is diatomic. Diatomic is only when they're by themselves. It's got a new partner. It's with K. It's with Kl, or K is with Cl now. That subscript comes from this 1 and this 1. They're 1 and 1. Plus Br. And if you look at your diatomics, Mr. Arnold, you're in the way. If you look at your diatomics, you see that Br is a diatomic and you need a 2 there, right? Because there are those elements that cannot be alone because they're so electronegative, and Br is one of them. Okay, and that is it for formulas. Now it's time to balance. 2 Brs, 2 Brs. 2 Ks, 2 Ks. 2 Cls. Hey, there's already 2 Cls. We can put 1s there for fun. It's kind of fun. A little bit. All right? So that's how that works out. All right, I'm going to throw one more down here. Oh, let's do the last one. All right, so this is a double replacement. And so we have a double replacement reaction here. In this case, we have Fe plus 3, so iron 3 nitrate plus silver chloride. And the charges are a little askew, but we can tell that Fe is supposed to be plus 3. And so we're going to put Fe down here. And it's plus 3, so write a plus 3 above it, or mental note. And then we have Cl. Cl is minus 1. I'm going to put it above since I'm writing like this. It just looks prettier. All right, and so we crisscross. We need a 3 there, right? That's where the 3 comes from, right? That's what we do. Plus Ag. And Ag is with NO3. Now, that subscript for the NO3, I am taking that across the yield sign, but the reason is because it's a polyatomic ion. It's in parentheses. It's sticking together. NO3 is staying together. But what we don't take across is this 3 right here, because that 3 is telling how many nitrates we have hooked onto iron, right? And we had 3 hooked onto iron, but silver has a plus 1 charge, and nitrate has a minus 1 charge, and so there's only spot for 1. And so there's 1 silver for every 1 nitrate. So those formulas are correct, and they are done. Now we have to balance. We have 3 nitrates on the left. Now we have 3 silver nitrates on the right. So we have 3 nitrates and 3 silvers. We put another 3 here. That gives me 3 silvers on the left, but it also gives me 3 Cls, right? 3 silver chlorides. And then we go back and look at the iron chloride. It already has 3 Cls attached to it. So we can throw 1 in there if you want, or it's optional. Throw 1 in there because that's where we started, and we're done. All right? So you have to go through all the steps. You have to follow the pattern. You have to first figure out what type of reaction it is. Second, you have to write the formulas correctly, crisscross, everything that goes with that. If it's crisscross, reduce it, whatever you have to do, but the formulas have to be right. Only then can you balance it and have it work. If you ever get to a point where you're balancing and balancing and balancing and balancing and balancing, and it's going around in a spiral, and the numbers, the coefficients keep getting larger and larger and larger, and it never seems to stop, well, you are in the death spiral. That means that you have accidentally forgot a subscript or put a wrong subscript or something's weird. Stop the balancing. Erase all the large numbers you have in front and go back, check the charges, and figure out what those subscripts are supposed to be, because I can guarantee you have a subscript that's wrong. And then after you fix that, it should balance pretty easily, especially these. All right. Hey, that's all I have. Good luck with this. It shouldn't be that hard. And just to submit it, and we'll get it graded. And if you have to redo it, we'll send that back to you, so you'll know. All right. Hey, thanks a lot. Have a good day.